In this section of notes, we're going to be looking at significance tests for a difference in proportions. Now, we've already done a few significance tests just for one proportion, and very similarly, your null hypothesis was that your proportion was equal to some hypothesized value. Here, our difference in proportions is going to be equal to some hypothesized value. However, we're only going to be doing problems where that hypothesized value is 0. So there would be two ways that you could write your null hypothesis. You could either write it as the difference equals 0, or if you were to take that equation and rearrange it by adding p sub 2 to each side, you could say your null hypothesis is that the proportion for group 1 is equal to the proportion for group 2. Your alternative, very similar to our one proportion tests, they can either be greater than, less than, or not equal to your hypothesized value. In this case, that would be 0. If you were writing them in this format, then again, you would just change this middle sign to either a greater than, a less than, or a not equal to. Now, there is one thing that is going to be a big change for us compared to the confidence intervals that we recently did for working with two proportions, and also from the one sample proportion test that we were working on, is that in this case, we were assuming that the two proportions are equal. And if we're assuming they're equal, we can't really then turn around and act as though they're different. So we're going to calculate some value that we're going to call p hat sub c, which stands for p hat combined. And the way you do that is you take all of your successes, add them up, that's your new numerator, and all of your trials, add them up, that's your new denominator. So we're going to use that value in any place where we would have used the p sub 1s or the p sub 2s. So these were our conditions when we were checking to do a confidence interval for difference of proportions. And most of this is going to stay the same. We are still going to check that we've got independent random samples or that we've got randomized experiments, so we're randomly assigning them. We're still going to check the 10% condition twice, once for each population. And we are still going to do large counts, and we are still going to check it twice. But again, because we are assuming that the two proportions are equal, we're going to switch any place where we would have used the sub 1 or the sub 2, we're going to change them to sub c's. So we're going to use that combined proportion rather than the individual ones. You still got a total of 4 little multiplication problems, and you still need to check them all, and you still need to verify that they're all at least 10. Remember that if one of those conditions is not met, you can continue with the rest of the procedures, but at the end, when you have your conclusion sentence, you just add something about how you should be proceeding with caution because such and such a condition was not met. But otherwise, other than changing the subscripts and using the p sub c or the pooled p or the combined p, make sure everything else is the same. Continuing on, we have our test statistic. So in words, we've got this general formula that we've used for our other significance tests. We're going to continue to use that. Now, in this case, we are assuming that the difference is 0. So our parameter is going to be a 0. And again, we're using the p sub c when we go to do our standard deviation formula here in a moment, because we are assuming that those values are equal. So here is that formula for our standard deviation of the statistic, but with the subscripts of 1 and 2 replaced with the subscripts of c, because we're using that combined or pooled p hat value. Now, when you go to find your p value, don't forget that if you're going to do it by hand using the table and you're doing a two-sided test, don't forget that you then need to double whatever that p value was. Now, there is a way to do this on your calculator. I'd suggest making sure you watch that video before you go to do the practice problems, because it's much more efficient to be using your calculator. Similar to what you did in the past, the only thing that's going to change is that do step, where you can show a little bit less work, and you can just write down your calculator commands and your calculator inputs, and then write down the output. And then that also takes care of this p-value thing for you, where you don't have to worry about, do I just take the p-value that I have? Do I double it? Do I subtract from 100%? That takes care of that for you and makes it a little bit easier. So again, make sure you learn how to do the significance test for a difference of proportions on your calculator by watching the other video, and then try the practice problems.